is one of the best questions which has been given in CSIR NET from the number theory in December 23. That means today. Here the question is asked, let n is an integer be such that n is congruent to 1 modulo 7 and n is congruent to 4 modulo 15, then which of the following are true? There are four options, A, B, C and D. So now for solving this question, we need to recall two important facts. The first fact is let m1, m2 both are positive integers and ab are any integer, then the system of linear congruence x is congruent to a mod m1 and x is congruent to b mod m2 has simultaneous solution if and only if a minus b is divisible by GCD of m1 and m2. So just you will check here, you have given the simultaneous equation linear congruence, n is congruent to 1 mod 7 and n is congruent to 4 mod 15. So here you calculate GCD of m1, m2, 7 and 15. This is 1 and a minus b, this is 1 minus 4 minus 3. So GCD of 7 and 15, this is 1 that divides 3 minus 3, and hence we say that linear congruence, system of linear congruence has a simultaneous solution, has simultaneous solution. Now here you will see n is congruent to 1 mod 7. That means here n equals to 1 plus 7 k1 for some k1 belongs to z. Again n is congruent to 4 mod 15. That means n equals to 4 plus 15 k2 for some k2 belongs to z. So if we think they have a common solution, so in that case, if they have a simultaneous or common solution, so thus 1 plus 7 k1 equals to 4 plus 15 k2 for some k1 k2 belongs to, as they have common solution. So in that case, that means 7 k1 minus 15 k2 equals to 3. Now here I have given another problem that is another fact. Find two integers u and v such that 7u plus 15v equals to 3. Well, with the help of division algorithm, we can find out here u equals to 9 and v equals to minus 4. So in that case, if we take k1 equals to 9 and k2 equals to 4, so you will see the value is basically 7 into 9 minus 15 into 4, this is 3. So for k1 equals to 9 and k2 equals to 4, this equation is valid. So now we put k1, the value of k1 here or k2 here. So for k1 equals to 9, what is our n? Our n is basically 1 plus 7 into 9. So this is basically 64. Or you can put k2 equals to 4 and you will get the value of n is 64. Now you will check the 64 is congruent to 1 mod 3 or not. Yes, this is true because 64 minus 1, that means 63, that is divisible by 3, or you can say 3 divides 64 minus 1, 63. So this option is correct. Now if we divide 64 by 5, so the remainder is 4, that means 64 congruent to 4 mod 5. So this is not true. Again For option C, 64, if we divide 64 by 21, so that means 64 is congruent to 1 mod 21. So this is true. And for option D, 64, if we divide by 35, so that means 64 congruent to 29 mod 34. So this option is, that means it is not congruent to 1 mod 35. So this option is false. So here option A and option C are true. Option B and D are false. So these are the true options. Thank you so much.